again. Here we go. Okay, so we have this. Okay, so here, let me do this. Let me probably start. That's all right. Okay. So anyway, here's another example. Okay. So this is actually another one that we did last time as well. But again, I want to use proportions to solve it. I thought that'd be better. Okay, and we're recording good. All right. Again, I want to use proportions to solve it. So let's say for whatever reason, we are able to walk at a rate of 1.5 miles per hour. Again, this is what we did yesterday, but I want to solve it using proportions. So if we're able to walk at that rate, 1.5 miles per hour, the question is, how far can so how far can I walk if I walk for 4 hours non-stop? I did show with the factor label method, but I want to show now using proportions. So what's our rate? This is our rate. Again, I'm writing it as a fraction, which is a way to express a ratio. We have our rate here. This is our walking rate, or the speed at which we're walking. That's better. Okay? Okay. Now, we want to know how far we can walk for 4 hours. Okay? So again, we had this here. This is our rate at which we're walking. This is also the rate at which we're walking, right? X over 4, X miles over 4 hours. I mean, we don't know what X is, right? We don't know what X is, but still, X is how far we can walk in 4 hours. So both of these are going to be equal because both of them are rates dealing with how fast we walk, the speed at which we walk. So they're both equal to each other. They both specify how many miles we walk and how far we're walking. Wait, let me say it again. They both specify the speed at which we're walking, distance over time. But since they're equal, we can figure out what X is. X is how far we went. Okay, so we have our proportion, right? Just like before, what do? We're going to multiply, cross multiply, that is, and this is what we get. So on the right side here, of course, we just have X. This product actually turns out to be 6. So we get 6 equals X. Well, logically, it's better to, I guess, to have X equals 6. But basically what we get then is 6 miles. So we get 6 miles. Okay. Again, if you stopped over here and just wrote 6 miles, that's fine. I mean, theoretically, it's better. I mean, really, it's better to write this. But, I'm not going to get that picky. Okay, so again, this is another example. Could we have solved it using the factor label method? Yeah, we could have, but, this is another way. I just think this makes a little more sense, but hopefully I'm right. So that's number 1. Number 2, now the question is, okay, well, how long is it going to take for us to walk 9 miles? Okay, so again, we have our 2 rates, right? We have 1.5 miles per hour. That's the speed at which we're walking. Okay, and we're assuming we're walking at that same speed. So that rate could also be given by 9 miles per X hours. X is how long it takes us to walk this. In other words, both rates are specifying the rate at which we're walking. 1.5 miles per hour, 9 miles per X hours, but X we have to find. That's why they're equal. So again, it's just like before. What do? We're solving for X. X is on the bottom now. Again, you have to make sure your units are in the right place, in the right places. miles over hour, miles over hours. Okay. So we have that, solving for x. So we have this now. I took the units away, but they do also cancel. Solve x, we cross multiply, like so. And then from here, we divide. Or you could probably go from here straight to here if you want. Okay. I'm just showing all the steps because, again, I don't know everyone's math background. But either way, we get x is 9 over 1.5, which is 4. So x would be 4. So basically, I'm walking. It would take me 4 hours. Wait a minute. Okay. So okay, 4. Oh, that's right. That's right. Yeah. Okay. Good. Okay. I hesitate for a minute because I thought that was wrong, but it's right. All right. So we have that. Any questions at all?
Why isn't it 6?
Maybe, is it 6? Did I do something dumb? Because I made a mistake. It should be 6.
Yeah.
I'm sorry. So I was wrong. Let me fix that. Ay, vey, Izmir. Oh my goodness. All looking 6. See if I can fix that. Yeah, I was thinking also. All right, cool. Okay. Okay, thank you. Okay, any other questions? Okay. All right, so also remember how we dealt with unit conversions, right? Like cups and fluid ounces and all that. Here it was in the imperial system. You can actually work with unit conversions. That is, you can solve them using proportions. I mean, it does take, it's not that much more work than a factor label method, but it works. And what's nice also about using proportions, you actually only need one conversion factor. You only really need both if you're using the factor label method. Let's do an example actually. So this is our first example. So we want to know how many quarts are there in 35 cups. Okay, so in other words, what am I really asking? I'm asking this, to fill in the blank here. 35 cups is the same as how many quarts? How do we do that? Well, I did show the factor label method, but we're going to use proportions. And again, as I just said, you can really use either conversion factor. It doesn't matter. I think I actually, if I remember correctly, I used the first one, but I kind of chose that arbitrarily, so randomly. See? Right? That conversion, we're looking for 1 quart per 4 cups. The other conversion, X is how many quarts we have per 35 cups. Well, they have to equal each other. They both deal with converting quarts to cups. We have these two ratios which are equal. I mean, we have to figure out what X is. But again, that's easy. That's just cross multiplying. So we have 1 over 4 is X over 35. Just like before, we can take the cross product. Okay, so that's what we're doing. Then we want to get X, so we divide, and we get X is 35 over 4. Well, 5 over 4 equals X. I mean, so we get this. So it's about 8.75 quarts. And that's our answer. So I don't know. I mean, so again, I don't know if you think that's easier than the factor label method. I mean, it's just another way to do it. I mean, as you can see, it does take a little bit more work, although I probably wrote more than necessary, but it does take a little bit more work than the factor label method. But in the end, the idea is the same. I mean, in the end, you're just going to either multiply or divide. All right, so that's one example. Now, let's consider this one. So here, what we're looking at is cups and fluid ounces. Okay? So again, what I want is this. We want to know how many cups there are in 320 fluid ounces. So we want to fill in this blank here. Now, if we went back to that table, we would have to get one of those conversion factors between cups and fluid ounces. I mean, this is the one I'm using. It really doesn't matter which one you use. I mean, the only difference is that the other one would be this one flipped over or inverted. Maybe that's better. Okay, so what do we, well, we're going to form a proportion. X is how many cups we have, right? We have 8 fluid ounces per cup. Okay, so if we have 320 fluid ounces, we want to know how many cups that's equal to. Just like before, what do? We set them equal to each other. And how do we solve? We just cross multiply. Next. And again, make sure the units are in the corresponding spots. As you can see, we have cups on the bottom, fluid ounces on top. I mean, if you did by mistake flip one of these, your answer is not going to be right. Okay. So we have this. What do we do next? Same old story. We multiply. In this case, we have to also divide, right? We cross multiply to get 8x is 320 times 1, which is 320. Then we divide, finally here, and we get x is 40. So what we end up with is 40 cups. That's what we get. Okay, that's good. Let me just keep that. Let me just do some. Okay, so we just pause the recording again.